Alright, this video we're still talking about function notation, that type of thing. But in this video, we are actually going to look at graphs of functions. And by looking at the graph, we're going to determine the intervals on the function where the function is increasing. In other words, where it's going up. It looks like usually the graph will look like a climb. Actually, in this picture I've got here, you've got like a path of a football. So as that football is climbing up from left to right, it's increasing. Finding where the function is decreasing. So decreasing in the function is like where it's falling. So look at the path of the football. You have increasing up to a certain point to its maximum height, and then it starts decreasing. The function decreases. And then sometimes functions are constant. In other words, there's no increase or no decrease. They just kind of stay horizontal. So let's analyze a couple of graphs of functions and determine intervals on the function where the function is either increasing, decreasing, or where the function is constant. So if we start at 0 on this function, we've got looks like we've got swimming pool water level. So we've got a swimming pool, and we're talking about how the water level changes in it, in the number of hours to the number of gallons. So at 0 hours, of course, we've got 0 gallons, but as we start filling it up, the function's increasing up to a certain point. So it looks like that point right there where you have a change, it starts where we're 25. So from 0 to 25, we could say that that function is increasing. For your x values or your t values in this case, it looks like your function is going up from 0 up to like 3,000 between 0 and 25 hours. So the interval would be from 0 to 25. It'll be the increasing interval. Now, okay, we went to 25, so it stopped increasing there. Now, notice from 25 hours over to 50 hours, it looks like the 50 mark, yeah. From 25 over to 50, it doesn't go up, it doesn't go down, it stays horizontal, so we say that is constant. It also stays constant at 75 to 100. If you'll notice, there's another horizontal line. So it is constant on two different intervals between 25 and 50. And also, we'll use a union sign to tie those two intervals together. It's also constant from 75 to 100. Okay, now was there an interval where the number of gallons started to decrease? Okay, or where it starts falling from left to right? Right here, between 50 and 75, you can see the slanted down, like it's sliding down. So that's a decreasing interval. So it's decreasing on the interval between 50 and 75 hours. Okay, so it's very visual. You can see very well what's going on with your graph. Let's look at another one and discuss the intervals of increasing, decreasing, and where it might be constant. Here's a function that's been graphed. Notice it is a function. It would pass the vertical line test everywhere. So we want to talk about, first of all, where does it look like the function, if we start from the very left of it, we see here, it's going up forever to the left. But look, this looks like it's sliding down. If you're reading the graph from left to right like you would read a sentence, it looks like we're falling down on this interval right here. So from negative infinity, which would be all the way to the left here, it looks like, since it's going up, it's like from negative infinity, sliding down to the point right here at negative 2, where x is negative 2. So we're going to say that's decreasing. It's falling down. The function is getting smaller between negative infinity to negative 2. Now I don't see anywhere else it's decreasing necessarily. So at negative 2, notice we come down to that minimum point there. Then we're going to start to climb again. It goes up. So if it's going up or climbing from left to right, we know that is an increase. So that's increasing from negative 2 to 1 on the x values. Oops, I'm going to need to use brackets on that to talk about intervals of increasing, decreasing. So from negative 2 to positive 1, x value of positive 1. So from here It's climbing up and stops climbing right there. So that's where x is equal to 1. All right, and if you notice then to the right here, this is a horizontal line, which means it's not going to go up, it's not going to go down, it's going to remain constant. So we could say the function is constant on the interval from 1 to infinity. So that's just how you would describe the variation of functions like this to tell me the intervals